Q29, and here we have a proton enters a region where electric and magnetic fields are perpendicular to each other. Initial velocity v of the proton is perpendicular to both of those fields. Path of the proton is not deflected in the field. Okay, so we have the magnetic field going into the page. This and these electric fields going down, right? And this proton is going through. So the proton is replaced by an alpha particle that is also not deflected. What is the velocity of the alpha particle? Okay, so we need to look at what forces are acting on this proton and what is causing it to not be deflected. It is not deflected because the forces are balanced and there's no net force, right? So which causes no acceleration. And so therefore, we need to equate the magnetic force and the electric force on the proton. So Fm, which is QVB, and it's perpendicular, so sine theta just 1. So let's just say sine 91 is equal to the electric force, which is EQ F electric. And we can see these formulas on page 12 of the data booklet. Let's just write that down, page 12. And so QVB is equal to EQ. And what we see is that the charges cancel out. And what we know is that an alpha particle has a +2 charge and a proton has a +1 charge. And so what we realize is that the charges actually don't even matter. And so we have velocity is equal to the electric field strength divided by the magnetic field strength. And so actually the velocity should be the same and should be v for both, because this is neither of these are dependent on the mass or the charge.